So we are starting with algebra, and this is lecture number 3. And now we are talking about factorization, the heart and soul of mathematics, the heart and soul of algebra. Now, what does factorization actually means? Factorization, it means taking common. As much as you can take common, that is factorization. So first of all, what is factorization? Factorizing is the opposite of expanding brackets. If you have two brackets, let me give you an example. X plus 1 into x plus 2. If I multiply it out, this is x squared plus 2x plus x plus 2. And this comes out to be x squared plus 3x plus 2. And we all know the way that we multiply, which we have seen in the previous 2 lectures. That is how the multiplication took place. And what you get over here, that is the answer. Now, this step going in this particular direction, like this is expansion, algebraic expansion. And if we go the other way, going this way, from these two brackets, this particular thing into the original brackets. So x squared plus 3x plus 2, if I break it down, and I get the answer as x plus 1 by whichever method, this is known as factorization. So factorization is the opposite of expanding brackets. Now, what else does it say? You look for a common factor for all the terms in an expression and take it outside. So this is the keyword, that is taking it outside the brackets. To factorize an expression fully, look for the highest common factor of all the terms. For a lot of these questions, you will need to remember how to divide the power. That means it is related with indices also. So now let's get started with the basic idea. Example 1. It says factorize the expression. Now we have 12x, we have 18y. X and y are uncommon. There is nothing to take common. But what about 12 and 18? We know that 6 into 2 is 12. 6 into 3 is 18. That means we can take 6 common out. So let me write it down. Even though it's a worked example, still I'm working it out. Let's take 6 common. We are left with 2x. We are left with 3y. So that is what factorization is all about. That's how we factorize. So I hope this first example is very basic, very clear. So example 1, is it all good, all clear? Just put a tick mark over there in the WhatsApp group. Now the first example is done. Let me move to the next one. Now this time what we are doing in example 2, that is, it's asking us to factorize and factorize 3x squared plus 2x. This time 3 and 2, they are not common, but x squared is basically x into x. So yes, I can take an x common out. So let me write it down. This is 3x squared plus 2x. We will write x common out, take it outside of the bracket. And then this is 3x plus 2. And that is the answer for this particular part. So these are basic examples. Now, exercise 1. Now, remember, there is a book that I've shared. Again, I'm just focusing on the book. I want the basics to be super. So we are doing the exercises from there. Now, factorize the following expression. For example, if I look at part A, 2a plus 10. So what can you factorize? You can factorize, you can take 2 common, you can write a, and you can write 5. Because 2 into a is 2a, 2 into 5 is 10. That is perfect example. Similarly, if I talk about part F, 9c minus 12d. This is 9c minus 12d. I can take 3 common. 3 3s are 9, so 3c is left. 3 4s are 12, 4d is left. That is the answer. Similarly, if I focus on J, so in part J, this is 3c plus 15d square. I can take 3 common out. So this is c plus 5d square. That is the answer. And this exercise 1 is basically like example 1. So we are taking numbers common, and exercise 2 probably would be taking variables common. So that is the basic theme that we are following. Now, if we talk about question 2, this is about division. This is about using the rules of indices, a power m over a power n. That is a m minus n. That is the basic rule. So therefore, if I talk about question 2, x square over x, that is x square divided by x. This can be done in 2 ways. Method 1, x square is x into x over x. Cancel out the x, you are left with an x. That's one approach. The other approach, x square over x, this is x square over x power 1, which is x2 minus 1, which is x power 1, which is x. So this is using indices, this is using algebra. Technically, algebra is, indices is part of algebra, but just a different perspective. Similarly, if I talk about f, so this is part A, this is part F, 24m square divided by 3m. So basically, this is 24 over 3. This is m into m over m. And we do the cancellation. The m and the m cancel out. 3 1s are, 3 8s are. This comes out to be 8m. That is the answer. Now let's look at question 3. So question 3 is basically like example 2. The worked example 2 that we saw earlier, that is taking variables common out. That is the kind of thing that this is. So let me look at part A. 3a square plus 7a. Take a common out. 3a plus 7. The next one, 15y minus 7y square. F. 15y minus 7y square. Take y common out. That is 15 minus 7y. Something like part L. That is 22w minus 5w power 4. So that is w common, 22 minus 5w cube. Now, I think everyone is aware of the fact that this w4 is basically w into w into w into w. So this is basically w cube into w. So if someone wants to add an extra step, they can write it like this: 22w minus 5w cube into w. And now we are taking this w common out. And what are we left with? 22 minus 5w cube. I hope I have explained this further using this particular technique. So now, so far so good. 2 examples are done. So inshallah, today we'll be doing lots and lots of factorization. Now look at example 3. Now example 3, it's a combo of example 1 and example 2. Not only will you take numbers common out, you will also take the variables common out. So you will be taking the factorization, the taking common of both the things. So that's how the examination question is built. Now let me just have a look. Okay, that's all good. Factorize 15x square minus 10xy. If I write this thing as 15 as 5 into 2, 5 into 2 into x minus 5. Actually, that one is, this is 2, this is x, this is y. And let me just change this. Let me make it smaller. So this is 5 into 3. 5 3s are 15, 5 2s are 10. Now, this 5 is taken common out. This x is taken common out. So basically, we have taken 5x common out. So this is 5x. What am I left with? I'm left with 3x minus 2y. So that is the basic knowledge that we are applying. Now, someone can ask this question, is it necessary to show the step? No, it's not necessary. But to make things clear for you people at the beginning, at the initial stage, I think it's a good idea to show it to this much of extent. So now look at this 4. So this example 4, question 4 is based upon example 3. Naturally, that is why it's right after that. So part A, this is 15A plus 10AB. What should be taken common out? A and 5. 5 common, 3, and this is 2, and this is B. It's always a good idea to double check. And this, don't forget the A. I forgot the A. Actually, I think I forgot to take the A common in the beginning. My bad. So now let's say I made this mistake. Let me do it again by making a mistake. I took 5 common out. I wrote 3A and I wrote 2AB. This is incomplete. The question is not complete yet. And then I realized I should have taken the A common out also. So now this is 5, this is A, this is 3 plus 2B, and that is the answer. Always a good idea to double check. And this is just for a double check. And this is visually that I'm doing. I'm doing a double check. And what is that? That is 5A into 3, 15A. 5A into 2B. 5 into 2 is 10. A into B is AB. It's all good, all clear. You check it before the examiner does. So that is the first thing. Let me show you another example. Something like C. Not B, actually C. So this is A, this is C. 16xy minus 4y. So now I'm taking 4 common, I'm taking y common, I'm left with 4x, I'm left with 1. Double check. Again, 4y into 4x, that is 16xy. 4y into 1, that is 4y. So this is also good, also perfect. Factorize the following expression. Now, I'll pause the recording for a while. Let me mark some questions. You will try it out. And then I'll solve it after you have tried it out. Very simple, very basic. So this is 5. And then try out A and F and K and L. Try these 4 out. Till that time, let me pause the recording. So now let's try out these 4 parts. This is part A, part F, K, and L. So this is A. That is 10p square plus 15pq. 5 can be taken common. P can be taken common. This is 2p plus 3q. Part F. That is 14x square minus 28xy square. 14 can be taken common, x can be taken common. So this is x minus 2y square. Okay. K. 8a square plus 6a power 4b square. And this is 2 common, a square common, and 4. And this is 3a square b square. And the last one, L, that is 24x cubed y minus 16x square. So 8 common, x square common, x is left, y is left, minus 2. Let me double check this one. 8 into x square into x, that is x cubed into y. 8x square into 2, yes, that is perfect. So I am already done with these 4 parts. I hope everyone got it all correct, all good. Now, exercise 2, something of the same type. Again, I would like you to try these out. The same kind of questions. They look a bit more complex. Part A, part J, part D, and O. Try these four out. So now let's look at part A. Part A करते हैं, यहाँ पे D लिखते हैं, उसके बाद यहाँ पर J and this one is O. Part A, x power 6, x power 4 minus x power 5. I think we will take x power 4 common out. The greatest highest common factor, x square is left, 1 is left, x is left. Part D, this is 12y power 6, 6y power 4. This is y power 4 is taken common out, 6 is taken common out. This is 2y square, and this is 1. And then J, this is 9a power 4b plus 27ab cube. So I can take 9 common out, I can take a common out, I can take b common out. So 9ab, I'm left with a cube. 27, 3 is left, a is gone, b is gone, b square is left. And last, that is O, 36 x power 7 y power 2 plus 8 x square y power 9. So now out of these 36 and 8, what should I take common? 4. So I'll take 4 common. 4 9s are 36, 4 2s are 8. And out of x power 7, x power 2, I'll take, let me just shift this thing to the side. I'll take x square common, and I'm left with x power 5. I'm simply left with a 1. And then the last one, y square and y power 9. So y square is taken common. I'm left with a 1, and I'm left with y power 7. So let me just close the bracket, and I think it's all good, all clear. No harm in double check. 4 9s are 36, x square into x5, x7, y square into 1 is y square. 4 into 2 is 8, x square into 1 is x square, y square into y7 is y power 9. All good, all clear. So is everyone clear on this? I need acknowledgement on the WhatsApp group. Everyone on the same single WhatsApp group, please acknowledge. So this is exercise 2, question 2. I'm just writing for reference. Exercise 2. This is question 2. Now this time we are starting with the factorizing of a quadratic expression. Now, first of all, what is a quadratic expression? A quadratic expression is one of the form ax squared plus bx plus c, where a, b, c are constants. That means the highest power in a quadratic expression is 2. So highest power is 2. There is an x squared term, there is an x term, there is a constant. This is a quadratic. For example, there are 2 quadratics that you see, and the process by which we will break it up, it's called middle term factorization. So now we are starting with this, the first one. Example 1, x squared plus 6x plus 8. Now, what do we do in this thing? X squared plus 6x plus 8. In this one, we take the coefficient of the x squared term. We multiply it with the constant. 1 into 8 is 8. We break the middle term in such a way that the equation is unaltered. At the same time, the coefficients multiply to give 8, the same number. Now, let's say if I write x plus 5x, the equation is unchanged, but it's not giving me 8. If I write 2x plus 4x, yes, it's giving me 8. So therefore, I'll write 2x plus 4x, and this x squared as it is, this 8 as it is. Now the equation is unaltered. And now what do we have to do? we have to make two what you call groups, the first group and the second group. Now, from the first group, if I take common, that is x, x plus 2. From the second group, if I take 4 common, I'm left with x plus 2. Is everyone clear on this? Because middle term factorization comes a lot in the exams. So let me just write it again. X squared plus 2x, you will take common and you will get this. Similarly, you will take common 4x plus 8 and you will get this. Now, what you will observe is that x plus 2, not this marker, the other one, you will observe that x plus 2 is common. The bracket can be taken common. So x plus 2 is there. And then we are left with x plus 4, because if x plus 2 is taken common, x and 4 is left. That is the first example of middle term factorization. Let me explain it again. We take the highest power, we take the coefficient of the quadratic, we take the constant, we multiply it, we break the middle term in such a way that the equation, actually it's not an equation, it's an expression. The expression is unaltered. At the same time, the coefficients should multiply to give you this number. So 1x plus 5x is not giving me this, but 2x plus 4x is giving me this. You make two separate groups. You take common, and you are left with x plus 2, x plus 2. Now you take x plus 2 common, you write it over here. What is left? X and 4. And that is the answer for this particular part. Now let's read. Now all these PDFs that I'll share, they are for you to read also. Find two numbers that add up to 6 and multiply to 8 over here. You can check this by expanding the brackets. So this 1 and 2 is for part A. So let me just write it down over here. So for part A, this is 1 and 2. For part B, this is 1 and 2. So now if I focus on this one, so 4 plus 2 is 6, 4 into 2 is 8, and then it's the same process as I've shown. Now let me do one more. The next one, x squared plus 2x minus 15. So x squared plus 2x minus 15. This coefficient is 1. This is negative 15. 1 into negative 15 is negative 15. Now let's break up this 2x in such a way that it multiplies to give you negative 15. If I write, let's say, 8x and 6x negative, it's not giving me negative 15. Basically, I'm looking for factors of 15 and take care of the positive negative sign. So we know that 5 and 3 is 15. So positive 5x, negative 3x. Yes, that is giving me 2x. So this is 5x, this is negative 3x, this negative 15 as it is, this x squared as it is. I think it's all good, all set. Take common. So that is x, x plus 5. Take negative 3 common, x plus 5. It's all good. Now x plus 5 is taken common. So we are left with x plus 5. And what are we left with? We are left with x minus 3. So this is x minus 3. So the whole purpose of understanding everything is necessary. But the main, most important thing is middle term factorization. So that is how this is done. Now I'll again pause the recording over here. And this is exercise 1, question number 1. I want you to try out A, B, and C. Try these 3. Let me pause the recording. So now let's try out these 3 parts. Part A, part B, part C. First of all, let me write down everyone. Each question, x squared plus 5x plus 6. The other one is a squared plus 7a plus 12. This is part B. And the third one, x squared plus 8x plus 7. First one, 1 into 6 is 6. break the middle term. When we break the middle term, so 3 into 2, 3x plus 2x. And then 6 remains, x squared remains. Take common, x plus 3 plus 2 common x plus 3. Then x plus 3, x plus 2. That is the answer for this particular part. Let me shift this down a bit. Okay, let me just shift this down. Okay, now part B. 1 into 12 is 12. 4 into 3. 4a plus 3a. And then 12 over here. A square over here. Take common, a plus 4. 3 common, a plus 4. So a plus 4, a plus 3. Now over here, 1 into 7 is 7. Break the middle term, that is x plus 7x. And then there is a 7 over here. There is an x square over here, x plus 1 plus 7, x plus 1. So therefore, this is x plus 1, x plus 7. All good, all clear. They were all with positive sign. Let's try out something different. Question 2, something with a negative, d and h. So d and h, you try it out. I'll just write it down first. So this is d. That is x squared minus 5x plus 4. And this is h, x squared minus 2x minus 15. I'll just pause the recording. So now it's again middle term factorization, but with a negative sign. It causes trouble to people. 1 into 4 is 4. Break negative 5x in such a way. So what if I write negative 4x, negative x? This adds up to negative 5, but this negative multiplies and gives us positive 4. All good, all clear? So let me write it down. This is plus 4 over here. This is x squared over here. This is x common, x minus 4. This is minus 1 common, x minus 4. And then x minus 4 is taken common. So x minus 4, x minus 1. Always you have the liberty of multiplying it out and double check if you are unsure at the beginning. Similarly, over here, this is 1. This is negative 15. That is negative 15. Break negative 2x in such a way. So what if I write negative 5x plus 3x? This adds up to negative 2x. This multiplies to negative 15. So therefore, x squared minus 5x plus 3x minus 15. X common, x minus 5 plus 3 common, x minus 5. X minus 5 is taken common. And what are we left with? We are left with x plus 3. So I hope you are all following and this is all good, all clear. Now, a little bit more complicated example. This time, the coefficient of x squared is not 1. The rule still remains the same. Let me solve it for you. 2x squared minus 5x minus 3. If I focus on 2, if I focus on negative 3, 2 into negative 3 is negative 6. I need to break this negative 5x in such a way so that it multiplies to give me negative 6. Now, what if I write negative 2x, negative 3x? Yes, it's adding up to negative 5, but it's not multiplying to give me this thing. What if I write negative 6x plus x? I think that would serve the purpose. So negative 6x plus x, that is over here. And this is 2x squared, and this is negative 3. If I'm not mistaken, let me continue with this. So this is 2x, x minus 3 plus 1. If nothing is common, we can always write 1 common, x minus 3. All good. So this is x minus 3 to x plus 1. A word of caution over here. It is necessary that this has to be common. This has to be the same. Otherwise, you cannot take common. Unless and until it's the same, how will you take common? So this is necessary. So now let me solve one or two questions over here. Something like this. Let me solve part B, and let me solve part C. So part B, part C. So this is part B, this is part C. Part B is 3x squared minus 16x plus 5. And this is 5x squared minus 17x plus 6. Now, when you will try this out, the very big numbers, such as these three, I'm canceling it out. Because for these, we will use quadratic formula later on. So we won't waste our time in doing the factorization of this. The rest you can definitely try out, and that will be the homework. So now let me get started with this. This is 3. This is 5. 3 into 5 is 15. So I'll write negative 15x, negative x. That serves the purpose. This is 3x squared. This is plus 5. So 3x minus 5 minus 1x minus 5. These two are the same. So therefore, x minus 5, 3x minus 1. That is the answer. Similarly, over here, this is 5. This is 6. 5 into 6 is 30. So 15 into 2. So therefore, that is negative 15x, negative 2x plus 6. And this is 5x squared. So 5x common, x minus 3, minus 2 common, x minus 3. Again, these two are the same. So therefore, this is x minus 3, 5x minus 2. We are just doing the factorization. And another question of the same sort, let me explain it to you. This is 6x squared minus 19x plus 10. So there is 6 over here. There is 10 over here. 6 into 10 is 60. So 19, I think 15 into 4. So that is negative 15x, negative 4x plus 10. This is 6x squared. The same thing. And now from these two, I can take 3x common out. And this is 2x minus 5. Let me double check. 3x into 2x, 6x squared. 3x into minus 5, minus 15x. All good. From here, from 4 and 10, let me take 2 common out. So therefore, if I take actually negative 2 common out, so this is 2x minus 5. So now these two are the same. Therefore, 2x minus 5. And this is 3x minus 2. So that's how this thing is done. Again, something with very big numbers. I think I'll just skip this one. The rest are good for you to try it out. And the last thing, since we are doing everything in totality, so this is part of factorization. Let's go ahead and solve it. Difference of two squares. This is the thing that we follow. A squared minus b squared, that is a plus b, a minus b. Now we know that if I multiply a plus b into a plus b, this becomes a squared plus 2ab plus b squared. If I multiply a minus b with a minus b, that is a squared minus 2ab plus b squared. But what if I multiply a plus b with a minus b? So this is a squared and then negative ab, positive ab, negative b squared. These two cancel out. I'm left with a squared minus b squared. In other words, if I write it like this, a squared minus b squared, that can be written as a plus b, a minus b. Example, that's right over here, x squared minus 16. X squared minus 16 is basically x squared minus 4 squared. Now it's of this category, a squared minus b squared. So what is a? X. What is b? 4. So therefore, this is x plus 4, x minus 4. Let me give you another example. X squared minus 9. This is x squared minus 3 squared. Therefore, x plus 3, x minus 3. Similarly, if we have x squared minus 36, that is x squared minus 6 squared, which will become x plus 6, x minus 6. So this is known as difference of two squares. There is a difference, and then there are two squares. What are the two squares? A squared and b squared. Another, I think we can all try this out. Let me try out D. So question number 1D, this is x squared minus 81. That is x squared minus 9 squared. This is x plus 9, x minus 9. And something like this, something more complex. 4x squared minus 49. So this is 4x squared minus 49. 4x squared can be written as 2 squared, x squared, 7 squared, which can be written as 2x whole squared minus 7 squared. Is this all good? All clear? So now this is 2x plus 7, and this is 2x minus 7. Something like 36 x squared minus 4. This is 6 squared, x squared minus 2 squared, which is 6x whole squared minus 2 squared. So therefore, this is 6x plus 2, 6x minus 2. Just acknowledge on the WhatsApp that this is all good, all clear. Let me explain part F. That is 16z squared minus 1. That is 4 squared, z squared minus 1 squared. That is 4z whole squared minus 1 squared, which is 4z plus 1, 4z minus 1. And then there is a mixed exercise on this thing. So we are now done with lecture number 3 of algebra, and we have thoroughly in and out studies factorization. So factorization is done and dusted. In the next class, we will delve deeper into the concept of algebra. Till the next class, take care.